This is the problem number 22. The problem states that consider a three-dimensional vector space spanned by an orthonormal basis. Cats 1, 2, 3, that the cats alpha and beta are given by, and they are the alpha cats is equal to I 1 minus 2 2 minus I 3, and the beta cats is equal to I 1 and plus 2 3. In first part of the question, we have to construct the cats alpha. Cats alpha is given that we have to construct the graph, that is complex conjugate of this alpha and the beta in terms of brave 1, 2 and 3. That we first find out the alpha in terms of the cats. One cats are given, then in terms of the beta 1, 2 and 3. Let's find out this value. Here the value of this bray can be obtained by taking the complex conjugate of this, that is alpha, and the complex conjugate of this. So let's take the complex conjugate of this, that is I 1 complex conjugate minus 2 2 complex conjugate minus I root 3, oh sorry, I gets 3 and the complex conjugate. Hence this value of alpha will be, this will be minus I, and this convert into bracket minus, because here there is no imaginary, no complex, that is it will be 2 and 2, and it will be minus I, that is it plus and 3. Similarly we can find the beta is equal to, by taking the complex conjugate, it will be minus 1 and plus 2 and 3. In the B part of the question, find alpha beta, that is this alpha and beta, and then we have to find beta and alpha beta and the beta alpha, and confirm that third is beta alpha is the complex conjugate of alpha and beta. So first find out this value here, alpha and the beta, and this is value here, that is minus I 1 minus 2 and plus I root 3, I sorry I cat 3, and the beta is given here, that is my this I 1 plus 2 3. Now take the multiplication of these. This minus I, that is I square, and this will be plus 1, and here this 1, thus 1 and minus this, that is minus 2i 1 and 3, and then minus 2i 2 and 1 minus 4 2 3 plus I square, that is minus 1, this I that is minus 1, and this is 3 and this is 1, and last that is plus 2i, and this is 3 and this is 3. As in the question it is given, they are the orthonormal basis. Orthonormal basis means, that means the value of this 1 is equal to 2 2 is equal to 3 3 is equal to 1, and others are 0, that is 1 2 is equal to here 2 3 and 1 3, and others are 0. And thus this alpha beta is equal to, first part is 1, this part is 0, this is 0, this part 0, this also 0 0, so hence only, and this 1 plus 2i, the value of this will be 1 plus 2i. Now next we have to find out this value beta and alpha. Second, beta and alpha, we have to follow the same procedure, that is beta is equal to minus I 1 plus 2 3, and alpha, that is cat, and cat is I 1 minus 2 2 minus I 3, and here we can do directly now, minus I, this is 1, that is I square minus 1, and this is minus, that it will be plus 1, and this is also 1 and 1, and others will be 0, and this 2 3, that is if I take multiple of this, it is 0, and this is also 0, and 2 3 it also 0, 3 2, and it is minus 2i and 3 and 3, that means it is 1 minus 2i. So it is beta and alpha. So from these two equations it is clear that alpha beta is equal to 1 plus 2i, and this is complex conjugator, that is beta alpha is a complex conjugate to each other. Next part of the question, uh, find all 9 matrix element of the operator A, and which is given, that is alpha beta in the basis, and construct the matrix A, and later you have to check the whether the matrix is hermitian or not. This is the C part. C part is given, the A operator is defined as alpha, cat, and beta. beta. So let's find out the value of this by taking the multiplication on these. So this alpha is, the states alpha is I 1 minus 2 2 minus I 3, and the beta is minus I state 1 plus 2 state 3. So this is the matrix, and we have to find out the, so here find all 9 matrix element of the this operator. So from here we will find, let's find out the elements of this matrix, that is A11 first element, and it is find out as state 1 alpha on this, and on this beta 1. And if you find this value 1 alpha, then you will get, here you can see this is alpha, and I am applying this on the this state. So here it will be 1, and this is I, and 1, and on this it will be 0 0 here, and here similarly we can apply here, that is beta 1, and beta is minus I, and here we will write, that is beta, that is minus I 1 and 1. The value of this is I, and the value of this will be minus I. So hence I square is minus 1, and it is that it will be plus 1. Now A12 is, that is 1 alpha and beta 2. So from here the value of this will be again I, and if we apply this beta on the state 2, then here because there is no state here, so it will be 0. A12 will be 0. Now A13 is equal to 1 alpha and beta 3. The value of this first is I, and the value of this beta 3, it is beta apply on the Kets 3. So here if we apply Cat, it will be 3, the value of this 3 3 and the Kets 3 will be 1, and the value of this, that is 2. So here will be 2, so it will be 2y. Now we have to find, that is A21. A21 will be 2 alpha and beta 1. Now we have to apply this bray on this alpha. So here you can see So this value will be minus 2 here, because the value of this will be 1. It is uh, it is minus 2, and the beta 1, this value is here minus I. This is minus I, and minus minus plus, that is it is plus 2I. A22 A22 is equal to 2 alpha and beta and 2, because the value of this is 0, so hence this is minus 2 and this is 0. It is equal to 0. A23 is equal to 2 alpha and beta 3 is equal to minus 2, and the value of this beta 3, that is plus 2. So it will be minus 4. Now A31 A31 is equal to 3 alpha and beta 1 is equal to 3 alpha, that means minus I. You can see here this is minus I, and this is minus I, and beta 1 is again minus I minus minus plus, I square minus 1, it is minus 1. A32 A32 3 states apply on this alpha, and beta apply on this 2, and because this value is 0, so here minus I, and this is 0, and this value is 0. Now A33 is equal to 3 alpha and beta 3 is equal to, this is minus I, and T3 is 2, so it is minus 2I. Thus the matrix A can be written as A11 is 1, A12 0, and this is 2I 0, minus 4, and minus 1 0, minus 2I. Now next step, whether this matrix is hermitian or not. So let's find out this. Check A operator matrix is hermitian or not. If this A dagger is equal to A, then it will be hermitian, and this A dagger is the A complex conjugate and then transpose. So let's find out this, and the complex conjugate of this matrix is equal to, so this 1 minus 2I and the plus 1, so it is 1 0, and this is minus 2I minus 2I 0 minus 4 minus 1 0 and plus 2. Now take the transpose of this, that is A dagger is equal to A complex conjugate, and then transpose is equal to this, convert row into column, that is 1 0 minus 2I minus 2I 0 minus 4 minus 1 0 and 2i, and you can see the this matrix and this matrix is not same, hence the given matrix, that is A, is not Hermitian. Thank you.